All right, this is a preview of Ledger hardware wallet integration with Bob Wallet for Handshake. It's a culmination of work by many contributors. Boimanya Fambala wrote the entire app for the device and the client, which was based on Ledger work by Nodar Chikwasilij for Bitcoin. Christopher Jeffrey added the compatibility for the Nano X device. Matt Slipper wrote the UI for Bob Wallet. And I've just been integrating everything together, squashing bugs, and now I think we're finally ready for production. So keep in mind, none of this software is released yet, and your experience may vary when it does finally go live. Really quick, so what is Ledger? It's a hardware wallet. I've got one here. You can see it's got two buttons on top and a tiny screen. There's a Nano S device and a Nano X device, which I'll demonstrate at the end. What is a hardware wallet? It basically serves two functions. It keeps your private keys safe, and it can still sign transactions. So when you initialize a wallet for the first time, it'll give you your seed phrase, which you will need to write down and back up, just like before with Bob Wallet. But this device will never reveal the private key once it's been generated. So it'll keep it safe. And the only thing it does is sign transactions, and it can also give you addresses as well. So that's the idea. It keeps the attack surface extremely low. Let's begin. So you'll notice that Bob Wallet has an extra button here, Connect Ledger, to create a new wallet. So we're going to start off by clicking that. The Kyokan terms of use are here. We'll accept those to proceed. And now Bob is asking us to connect the device. Open the Handshake app, enter the PIN. I've already got it connected to the computer. This is my testing device, of course, so I don't mind revealing my PIN code to you. It's 1234. You notice that I use the two buttons on top to enter the number, and then click the check mark. And you'll see there's a couple apps on here. You could have the Bitcoin, the Ethereum app as well. I've got the Handshake app installed. It's warning me the app is not genuine because I'm in debug mode. You'll also notice the little DBG in the corner here. So I'm going to skip past this. When this is in production, you won't have to worry about it. When the app is open, it'll tell you to connect it to Bob, basically. You can view the version number. 1.04 is a version that we are going to release, hopefully. Okay, so at this stage, the wallet is open. It's connected. We've entered the PIN. The Handshake app is open. So let's tell Bob that we're ready. It's going to connect to the device. And in a second, there we go. Now we're open. So what happened in that moment is the device, which already has the mnemonic seed generated, will provide for Bob the extended public key, or XPub. This is just a public key. There's no private key data involved. But now with this XPub, Bob is able to generate all of the addresses that the Ledger hardware wallet will be able to sign for. So for example, this address right here is the first address from the ledger, and we can start to use it right away. So I'm going to start off by generating 50 blocks. This is a testing environment, obviously, so I can generate blocks very quickly. And I've received 10,000 HNS from generating those blocks. So another interesting point about the Ledger wallet is it only needs to be connected to your computer when you are ready to sign a transaction. Once you have the public keys, like I've demonstrated, you can receive money, as you only need the device connected when you're ready to spend it. So let's try that. I'm going to come grab an address here and just do a little send to myself. I will send 1.12345 HNS with the standard fee rate. Click continue. Yes, these details look fine. And let's confirm. So here's where things start to get a little different from the usual Bob flow. Now this modal has popped up, and it's asking me to connect the device and enter the PIN and open the Handshake app, and we've already done all these things. So we'll click connect, and now the transaction is being generated by Bob with the public data and being transferred to the device for my approval, and then we'll sign it. So the device is asking me to verify these outputs. The way it works on the Nano S is there's two buttons on top, and you click them both together to kind of proceed. So verify output 1, that sounds good. I want to do that. Okay, yes, we want to verify output 1. Covenant type is none. That's going to get more interesting as the demonstration goes on. Yes, we're okay with that. Value is 1.123456. That's correct. Okay. Now, this is the address we are sending it to. We can make sure it matches what's on the screen. QWKZD. You can use the right arrow to scroll through to the end. This address ends with EC2N. That's correct. We'll proceed. Okay. The device is thinking. Fees are 0.0028 HNS. That's great. That is actually below the estimate from Bob Wallet. We're okay with that. And now we're done. The transaction has been sent. Pretty easy. So that whole process I did on the device is similar to entering your password into Bob to unlock your wallet, and then Bob Wallet would normally sign the transaction with the private keys stored in Bob Wallet. In this case, the transaction is being signed on the device. So we'll confirm that we received that in one block, and pretty easy. So now let's start doing some interesting Handshake stuff. I am going to open an auction for the name Calvin and Hobbes. Okay, we're going to start the auction, and the ledger modal pops up again. We'll connect to the ledger device and confirm this transaction on the device. Again, Bob is generating the transaction from the public data, public keys, sending it to the device to sign. Verify output 1, yes please. Covenant type open, that's cool. Okay. Oh, now look, we can review the name before we sign the transaction. That is the name I do want to open. Okay. Value is 0 because that's just the nature of open transactions on Handshake. They have 0 value. The address, this is generated by Bob. It comes back to our own wallet, so we don't really need to worry about it. And it's a 0 value anyway, so who cares? There's the fees. Now we're good. Great. So now we've opened an auction. We've sent an open transaction with a ledger device. I'm going to move the blockchain ahead 7 blocks so we can start bidding. 1, 2, 3, 4, 5, 6, 7. And now let's go back to the auction page, Calvin and Hobbes. Let's place our first bid. This one's going to be 1 HNS, no blind. Yes, I understand the bid cannot be changed. There's the ledger modal. The transaction is being generated by Bob, sending to the hardware device. We'll go through this process again. Output 1, yep. Bid, that's correct. Calvin and Hobbes, that's the name we want to bid on. Value is 1, that is also correct. There's the address. I'm not going to bother checking it. And the fee is pretty small. That's great. There we go. Bid has been placed. So this is all going pretty well. I'm going to bid, confirm that, and then bid a few more times. So we have a few more bids to play with here. This time I'm going to add a blind and say 18. So now the total transaction value will be 20. There's the ledger modal. We'll connect this again. Ledger will ask us to approve. Output 1, yep. Bid, yep. Calvin and Hobbes, yep. Value is 20, which makes sense. That's the lockup value. That's the actual amount of HNS that's going to be sent in this transaction. Ledger just wants me to make sure that the details on my computer screen match what's on the device. I'm going to do this one more time so we have 3 bids to reveal. It's important when you are reviewing the details on the device that they do match what is on the screen. And the reason is because the device is very, very hard to attack. It's supposedly the safest part of your whole setup. So even if there's a virus on your computer, it's very difficult to steal your money from the Ledger wallet. But if you notice that the address on the screen or the covenant type or the name or the fees seem wrong on the device, that's a red flag, and you should eject the device, review your security procedures, and try to see what went wrong. Okay, so now let's move ahead to the reveal, which looks like it's in 5 blocks from now. 1, 2, 3, 4, 5. Let's see. Okay, so now we're ready to reveal all 3 of these bids. As you know, you can reveal all 3 bids in one transaction, so hopefully this will work with the ledger as well. Bob is sending the transaction to the device. There we go. Output 1. Okay, yes, it's a reveal. Okay, yes, it's for Calvin and Hobbes. Value of 1. Okay, this is the first bid I placed. We're revealing it. Turns out the value was 1. That's what we're revealing. Verify output 2. Okay, yes, it's a reveal. Yes, it's Calvin and Hobbes. This value is 2. That was the second bid. I added a blind to it, so that's the correct reveal. Okay, I verify output 3. Okay, yes, it's another reveal. Okay, yes, Calvin and Hobbes. Okay, that reveal was for 5 HNS. Okay, the address is good. Okay, and then the fee is 0.01. All right, it's a pretty big transaction, so that sounds fair. There we go. We've now revealed this bid. So we've just gone through the entire auction flow where every transaction was signed by the ledger. Let's see, how far do I need to go to start doing some more fun stuff? About 10 blocks. Okay, so we'll go 10, and I'll even go one more. All right, so now we're ready to, actually the first thing we can do is reveal the bids that we lost, right? So here in the domains manager, we have these 3 bids, and we know that we can redeem the losing bids. So we use the redeem all function and click connect again, and this should redeem our 2 losing bids. We'll sign that transaction with the ledger. Output 1, okay. Yes, it's a redeem. Okay, yes, that's the name. That's the amount of my losing bid is 1 HNS. That's correct. Yep. Verify output 2. Great. Redeem is correct. That's the name. Value is 2. Great. That's the address. Okay. Fees are relatively small. Great. And there we go. All right, we'll just confirm that. Now we've got our 3 HNS losing bids back. And now I think we're ready to manage the domain. So we'll just add text record here, and we'll just write comics are fun. They sure are. That's good. Submit. Again, the ledger modal pops up. So now this should be a register covenant. We have just won this name. This is the first DNS update we've done with this name. Covenant type is register, both buttons to proceed. Okay. Calvin and Hobbes. Yep, that's correct. Okay. Value of 2. That's the amount of the winning, the second highest bid actually. That is the amount of coins that are locked forever to the name. We refer to them as burned. But every time you do make a transaction with that name, it's going to have that value. Okay. So this has been great. Everything's been sent, and we'll even confirm that. So now we have a registered name, and we've done all the transactions just like we always have done with Bob, but every time we sign now, we enter our PIN code and push some buttons on the ledger device, and the device will actually sign the transaction, send it back to Bob, which will broadcast it to the network. So now we can do some more fun stuff. The other thing that I've implemented is the atomic swaps function of Bob. Using the sig hash single reverse. Ledger device is aware of that sig hash type, and so this can be kind of cool. So what I'm going to do is now transfer the name to another address I own in my wallet, just to show you how the atomic swap will work, both sending and receiving with the device. So here, rs1qsdup, that is going to be the address I transfer the name to. So we'll go to our domain manager. We've already registered, so we can transfer. I'll put the address in there, and we'll initiate the transfer. There's our ledger modal again. Now the covenant type should be transfer. Verify output 1, that's what we want to do. Yes, it's a transfer. Yes, the name is Calvin and Hobbes, that is correct. Aha, new owner, rs1qsdup74. Yep, that's correct. We want to make sure we're transferring with this name to the correct owner, ends in 97G. Yep, that's correct. Okay, value of 2, like I said, that's the locked amount into the name. This address is our own address that is actually on the output of the transaction. And fees are 0.005, that's great. Okay, so that should be complete. Wonderful, so now we've initiated a transfer. I'm going to zip ahead 50 blocks now, this would be the 2-day waiting period until we can finalize the transfer. And so we could just finalize it, and I could demonstrate that later, but to make this a little more interesting, let's finalize with payment. I am going to make myself pay 123.456789 HNS for this name. This is the address that we initialized the transfer to. You might remember it from a moment ago. So we're going to finalize this. And now what's going to happen is, if you remember how atomic swaps work in Bob, we're only going to sign half the transaction. The buyer will finish the signature. So this is kind of interesting. A ledger will sign half the transaction and not broadcast it, and we'll be able to give the blob to our counterparty. So yes, we're going to verify output 1. It is a finalize. It is for the name Calvin and Hobbes. Okay. The value is 2. That's okay. That's the address that the name will be finalized to, the new owner. Okay. verify output 2. Yep. A covenant type none. This will be the payment to myself. I am selling the name. This is the amount that goes to me. So that's okay. And we can verify this is the address for my own wallet. Okay. And now here comes the fun part. SIG hash type, single reverse. This is plus anyone can pay. This is the magic trick about atomic swaps. And it's very, very cool that the ledger is telling the user that this is the way it's going to sign. So we needed the private key to sign this half of the transaction, but it has not been broadcast yet. Very exciting to me. Here is the blob we will send to the counterparty. I'm just going to copy it and click done. And then if you've ever done an atomic swap like this, now we're going to pretend, okay, that I'm the buyer of this name. I'm still using the same wallet and everything, but just bear with me here. The other person who's buying this name from me is going to see the similar screen, and they're going to click claim pay transfer, and they're going to paste that hex blob in there and verify it. So yes, this is the address we provided to the current name owner. This is our address. We're going to receive it. This is the address receiving funds is the original owner's address. They are getting the payment. 123.456.789 is what we agreed on. We are going to pay and swap the name. And this will all happen on Ledger as well. So the buyer of the name is going to verify output 1. Yes, it's a finalize. Yes, it's Calvin and Hobbes. Yes, it's the value of 2. This is our address that we provided in the very beginning. This is the address we want the name to go to. That's okay. Verify output 2. Thank you. Covenant type none because it's just a payment. We're just sending money. 123.456.789. Fantastic. That's good. That's the current name owner's address where the payment is going to be received. That's correct. Great. And fees are great. Okay, that's okay. And we're done. Keep in mind when you're seeing that that OK X checkmark thing, that's your opportunity to realize that something about the transaction is wrong, and you can exit, and Bob will show you the error, and that'll be done. So we've now finalized the name. It's a little hard to see because I'm using the same wallet for both the buyer and the seller, but the name has been transferred and now belongs to the new owner. We did an atomic swap with Ledger. So I think that's everything else I want to show you. You can still log out. You can add other wallets to Bob. Currently, you can only have one Ledger wallet with Bob at a time. That maybe we'll be able to change that in the future. You don't need to enter a password to unlock the wallet. You just click the button and it'll open up. That might be another thing that we can adjust in the future. And again, you do not need there, I've disconnected the device now. It's off. You can still generate receive addresses. You can still log out and log back into this wallet and view your portfolio. The only thing you won't be able to do is send money without the ledger attached. So let's try this again. I'm going to send 9.87654.3 HNS to another one of my addresses. And so, the transaction cannot be signed, will not be valid. You will not lose money until the device is plugged in. You go through that whole process. So you can keep this device very safe. Go about your day looking at your Bob wallet. When you're ready to send a transaction, you will need to connect it. Couldn't connect to our ledger. Let's try it just to run through the process one more time. So I'm going to put in my PIN code 1. Notice that the Ledger device will randomize the number that you start on every time you enter your PIN code. That makes it a lot harder for somebody in the same room to just count how many buttons you're clicking, maybe to try to guess what your PIN code is. The device is clever that way. So we've entered our PIN code. We've got the Handshake app open again. Now this should proceed as we've seen a moment ago. Verify output 1. Yep. Okay. Both buttons. None. Okay. Values 9/8. Yeah, that's fine. That's okay. The address, that's where I want to send it. QVM3. Yep, that's good. And maybe this time here, I'll go one more step and then we can look at it. Fees 0.0028. That's way too much. I'm going to click X. We're not going to pay that. And we'll get the error again. And so this transaction has not gone out. And we can just cancel out of this. And so that is a demonstration of a Bob wallet with the Ledger hardware wallet. This is the Ledger Nano S. The next thing I'm going to demonstrate is everything again, but with an emulated Ledger Nano X, which is their newer device that has more memory and a bigger screen. I do not have a physical Nano X, but Ledger has provided software to emulate the Nano X, and I'm going to demonstrate everything again using the virtual device. So that's what we're going to do next. Okay, we're back. This is Ledger Wallet integration with Bob Wallet for Handshake. I've just demonstrated the process on a physical Nano S device. This is going to be the same demonstration, but using a Nano X inside of an emulator called Speculos that is released by Ledger. It's a virtual environment that emulates the secure element on the actual physical device, and the app that is loaded into it is the app that the team has written and eventually will be released. So ideally, this emulated device is an accurate representation of the physical device's behavior. The Nano X has a lot more memory. You can load way more apps on it. I think it's like 100 apps. The Nano S can only load 3. There's more memory for the actual app to use. And it has a different user experience flow. It also has 3 lines of text instead of 2. So you notice the screens are a little bit easier to navigate. I can press the virtual buttons on the device using my keyboard here. So that's how it's going to work without a little tappy. All right, so we're going to do the whole presentation again. We're going to connect the ledger, accept Keokun's terms of use, and proceed. The device is virtually connected to the computer, so we're going to connect. Same as before, the device is providing to Bob Wallet an extended public key, an XPub, from which Bob can generate all the addresses it needs. It can watch the blockchain for all of your transactions, create new transactions, send them to the device to sign. I've actually used the same mnemonic phrase for this virtual device, so you notice the addresses will be the same as well. I'm going to start by generating 50 blocks, move the chain ahead, get us some money, and then we'll go grab an address here. I'll copy this one, and we'll just start off with a simple send. This is going to be 99.88.7766 HNS. Continue, please. Yes, we'll confirm these details. Again, you have to make sure the device is connected, which it is virtually. We'll connect, and then the virtual device will show us the flow. We want to verify output 1. Yes, we do. Covenant type is none. That's good because it's just a simple send. That is the value of the money we want to send. Yes, that's the address we're sending to. It's a little bit nicer on the Nano X. You can see the entire address on the screen. We want to accept this. You can also go one more step ahead to hit reject if the address is wrong. We're going to accept this. Fees are 0028. Wonderful. Accept, and we're good. Just like on the Nano S. So now I'm going to go through the whole process again with opening an auction. Let's do Snoopy this time. I'm going to start going a little quickly because you've already seen how great the process is with Nano. Covenant type open. Snoopy is correct, value 0. That's our address. We'll accept. Fees, that's great. Okay. We'll bump this ahead 7 blocks to get to the bidding phase. 1, 2, 3, 4, 5, 6, 7. Now we can place our first bid. First bid will be 123 HNS.456000. I don't know. That's fun. Amount. Submit. Connect. Device wants us to verify. Yes, it's a bid. Yes, it's for the name Snoopy. 123.456 is correct. That's the address. That's fine. We'll accept this. Fees are good. Fees are 00436. Okay. And there we go. Now I'm just going to generate 2 more bids like I did last time. This bid will be for, let's see, 25 HNS, and this time we'll add a 25 HNS blind. That should be a 50 HNS transaction. Submit, connect, switch to the device, verify the output, bid, Snoopy, 50 HNS, address, accept, fees, 0046, great, looking good. Let's do that one more time. This time we're gonna bid something 000123, really small bid. I don't know, maybe we'll get lucky and that'll be the winner. Verify details on the device. It's a bid, Snoopy, 000123. That's the address. We'll accept that. Fees are good. Accepted. Okay, great. So we've placed our bids. Let's move ahead to the reveal phase. How far away is that? 5 blocks. We'll just scoot ahead. 1, 2, 3, 4, 5. Okay, now we should be able to reveal all 3 of these bids in one transaction. We'll connect to the device again. Verify output 1 is a reveal Snoopy for 25. Yep. Verify output 2 is a reveal Snoopy 123.456. Yep, that's one of our bids. The third one is a reveal for Snoopy 00123. That's correct. That's the address. Yep, great. Fees are a little high because it's a big transaction. That's okay. And off it goes. Wonderful. So we'll confirm that and speed ahead 10 blocks so that we can manage the domain. I guess the first thing we'll want to do is redeem the losing bids. We'll do a redeem all from this screen. Connect. This should redeem our 2 losing bids. We're going to redeem the name Snoopy. 25 was the loser. Accept. Output 2, redeem Snoopy. 0.000123 was a loser. Accept. These are acceptable as well. Wonderful. That's working. Now we can register. We'll go to our Snoopy domain. We can register the domain. We'll just do the simple register in Bob this time without adding DNS data. Connect, verify output 1 is a register for the name Snoopy. Value is 25. That makes sense. It was the second highest bid. We'll accept, and the fees are 0.00426. We'll accept that as well. Great. And we'll just confirm this. And now that the name is registered, we can transfer it. I'm going to demonstrate the atomic swap process again with the Nano X that I've demonstrated with the Nano S. First, we'll go and receive and create a receive address, 8TMMR. Great. Then we'll go back to our Snoopy domain manager, go down to the transfer field, enter that address here, and initiate the transfer with Ledger. Yes, it's a transfer. Yes, the name is Snoopy. Is that the new owner? Let's see. RS1Q8TMMRF06LX. Yeah, pretty much looks right. Ends in 5Z3E. Great. That's definitely the address that we want the name to go to. Value is 25. This address is our own wallet. It's the output of the transfer covenant. We'll accept that. Fees are acceptable. We'll accept that as well. Great. Now we will... I'll generate 50 blocks, speed us ahead 2 days into the process, and just sort of refresh the UI here in Bob again. And we'll do the finalize with payment. This is going to be another atomic swap. This one, let's see, what should we charge for this? We got the name for 25 HNS. Let's sell it for 1,234.5656.99 HNS. Okay, and again, what's going to happen is we're going to sign half the transaction. The buyer of the name will sign the rest of the transaction and broadcast it. That's how the atomic swap works. So we're going to verify output 1. Yes, it's finalize. It's for the name Snoopy. Value 25 HNS is the locked value. That's the address that of the buyer. That's correct. The ATMMRF address, that's the right one. It matches what's on the screen. No malware. That's great. We're going to accept that. Output 2 is the payment to ourselves. We are the current name owner. This is what we're charging, 1,234.5656.99. That's the correct amount. That's our own wallet address. We're going to accept that too. And we're going to sign it SIG hash, single reverse, combined with anyone can pay. The string is a little truncated here, but that's what it means. This is the atomic swap SIG hash mode. And we'll accept that. And now note this transaction has not been broadcast because it's invalid. If you remember how atomic swaps work, we just have half a transaction here. And now we're going to pretend that we are the buyer of this name. So Snoopy wouldn't be here. This is somebody else who's buying the name. They also have a Ledger Nano X. They're going to claim paid transfer and complete the payment and sign the complete transaction with their Ledger Nano X. So we paste the blob here. And we'll verify that. Yes, this is our address to receive the name. This is the current name owner's address who's going to receive the payment. That's the price that we agreed on. Pay and transfer. Complete the process on the device. Verify output 1. Finalize is correct. Snoopy is correct. Value is the locked value. That's our address. We're receiving the name. Yes, I like that. We'll accept that. Verify output 2 is the payment to the current name owner. So it's a none covenant. That's the correct payment value. That's the name owner's address that they want to receive the money at. Everything looks good. Fees are good. We'll accept that, and we're done. And we'll just confirm that in a block. So again, I've used one wallet to show both the buyer and the seller side. But you know how this works in practice, they'd actually be two different people. So the name Snoopy hasn't really left my wallet. It's just changed hands from one address to the other, but we did it with an atomic swap. That's it. Everything works on the Nano X the same way it does on the Nano S. You can log out. This device is a little more tricky to disconnect for that type of demonstration, but you can see I can log in and out with the Nano X. And that's it. If you're able to review the pull requests to Bob Wallet or to Ledger, that'd be very helpful for some feedback. And we're able to update features on the device. If there's anything you want to see extra on the device screen during the approval process or in Bob Wallet, open an issue on GitHub. Anyway, thanks for your attention and thanks for your patience. I know Ledger has been something the community has wanted for a long time, and I think we're finally in field goal range here with that. And it took a lot of work from a lot of people. So thanks to everybody who contributed to the project, and handshake to the moon. Thank you.